Let's see here. We want to do the example in a more complex circuit, and here we want to set N1 here is stuck at 0, so this is connected to ground, right? So you know that if N1 is stuck at 0, we have to apply the opposite here in order to check at this specific node. So we want to apply N1 equals to 1, right? So how do we get N1 equals to 1? We will draw the truth table. For this is a NAND gate. So this NAND gate, it is A2, A3, and N1. A is 0, 0, it will produce a 1. 0, 1 is a 0, so it will produce a 1. 1, 0 will produce a 1. And 1, 1, it will produce a 0. Okay? So in order to apply N1 equals to 1, we can apply all these three values. Okay? So this is settled. Your test vector, you can apply these three values. Okay, now comes the harder part. We want to observe at Y what happens if N1 is stuck at 0. Okay, so now we have to do the truth table, the second truth table for these two, right? So this one you have N1, N3, and this is Y. It is still a NAND gate, so 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0. Okay, so what do we apply here? We want to check if N1 is stuck at 0. Okay, so here we want to find out what is at N3. Okay, this N3 should be a value which will point out the error at N1. So because this is a gate, a line that is within the gates, you cannot observe it directly. You cannot put a probe here directly. So we want to observe the output of N1 at actually the Y. So you want to see at Y what happens to N1. In order to do this, you need to propagate the output of N1 to Y. Okay? And in order to do that, we need to control N3. Okay. So let's see for the first case, right? We can choose N3 to be either 0 or 1. So let's try first. N3 equals to 0. Alright? If N3 equals to 0 and N1 is equals to 1, right? And N1 is equals to 1, which you apply. If N1 is not stuck at 0, N1 will become 1. So if you look at the truth table, N3 equals to 0 and N1 equals to 1, we are here, right? So Y will become 1. Alright? So what about the other case, right? The next case. N3 is still equals to 0 and 1 is stuck at 0. Therefore, N1 equals to 0. What will the Y be? So for that case, N3 is 0 and N1 is also 0. Y will still be 1. So here the Y doesn't change, so you cannot tell if the node N1 is actually stuck. So this means N3 equals to 0 is not good. Okay, so now we try something else. We try N3 equals to 1, right? If N1 is not stuck, then N1 equals to 1, N3 equals to 1, N1 equals to 1. then you will have here y equals to 0, and if n3 equals to 1 and 1 is stuck at 0, therefore n1 equals to 0, right? Then y is equals to 1. As you can see here when n1 is not stuck, y is equals to 0. When n1 is stuck, y equals to 1. So this y value changes. So this means this value is actually a good value. n3 equals to 1 is okay, right? So you want n3 to be 1. Okay? n3 to be 1. Okay, so how do we set n3 equals to 1? So now we have to look at this gate, right? So this is an NOR gate. So you have n2, a0, and n3. So 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0. Okay. So you want n3 to be 1, and n3 to be 1 is only one possibility, which is this one. Okay? So you know what is a0. Now you know n2 here is 0. So if n2 0, this is an inverter, so a1 equals to 1. So now we have the complete test vector. The test vector or the test pattern, you can arrange it from a3, a2, a1, and a0. So a3, you can choose any one here. So that means let's choose the first one. a3 and a2 equals to 0. a1, what is a1? a1 has to be 1 here, and a0 has to be 0. Okay, this is the first test vector. You can also use the second test vector here, in which a3 is 1, a2 is 0, and a1 and a0 is still the same. This is the second test vector. And the test vector is a3 equals to 0, a2 equals to 1, a1 equals to 1, and this. Okay, so this is your test